bases that are the same, you add the exponents. Okay, you have done that before. So this is more like a to the power of m times a to the power of n is equal to a to the power of m plus n. That's the first law of exponents. Okay? Please, you only add the exponents if the bases are the same and you are multiplying those bases. Okay? If the bases are not the same, you cannot add the exponents. Okay? You cannot add. Like for example, if I give you 2 to the power of 3, and I say this is times 3 to the power of 2, you cannot multiply the bases. You cannot multiply the bases, you cannot add the bases in that case. Okay? Then the second law, if you are dividing bases that are the same, you subtract the exponent. So a to the power of m divided by a to the power of n will be equal to a to the power of m minus n. Okay? That's the second law of exponents. It is only true if the bases are the same. The moment you have different bases, law 1, law 2 cease to exist. You cannot divide bases that are the same. You can divide, but you can't subtract their exponents. Okay? Now, there is also another law, which is in this case, law 3. So here, we can have two cases where either m is greater than n or n is greater than m, but it's still the same. Okay, so we have got A and B, it's exactly the same law. Okay, because sometimes you can have the m being greater than n, or you can have the n being greater than m. So these two are covered. They are both law 2. This is law 1. Right? Then law 3 now, if you are given a base raised to a specific power, okay, like that, or rather to a specific exponent, right? And then there is an exponent outside the bracket, right? Like that. You are allowed to multiply the exponent. Okay? So this will be equivalent to a to the power of m times n. Also, okay, this is also important. It's also the same as a to the power of n with the m outside. But you can switch the exponents, okay? Because the result is the same. Remember, if I give you, say, 2 times 3, this is the same as 3 times what? 2. It's the same thing. Okay? But we are mainly concerned with the product, this part here, where you multiply the what? The exponents. Okay? Then, now this one is very important, number 4. So, I've dealt with that. Then, number 4, right? Number 4, if you are multiplying bases and they are both raised to the same exponent, okay? You are allowed to distribute the exponent outside. Because remember, the exponent of this a is a 1, the exponent of the b is a 1. So this will be equivalent to a to the power of n times b to the power of 2. Okay? Now, I want you to look at this one now. It's very interesting. I'm not sure whether you did this last year. Do you see that the exponent is the same here? If we move from right to left, do you see that as long as the exponent is the same, we are allowed to multiply the what? The bases. If the exponent is the same, you can multiply the bases. Even though the bases are. Yeah. Let's say if I give you, for example, maybe 3 to the power of 2 times 5 to the power of 2, like this. Okay, I can determine the answer without using a calculator. So this will be equal to 3 times 5 squared, which will give me 15 squared, which is 225. Okay, remember, 3 squared is a 9. 5 squared is what? 25. What is 25 times 9? 225. Okay? Yeah, you must have a calculator in front of you. How can you come to a maths lesson or doing pure maths but you don't have a calculator in front of you? I don't need a calculator because I'm a calculator myself, so I do it like yeah, I never since you came to my class, you will see me using the calculator. The reason why I don't use the calculator because I want to make my brain as sharp as possible. Okay? So take note of that. Alright? Then number 5. Now, when you are dividing, if you have got a rational base, okay, by rational I mean a base which is a fraction. If it is raised to a specific exponent, okay, so like this. So here, if we have, say, a over b raised to the power of m, this is the same as a to the power of m divided by b to the power of m. Okay? Is the same. So you distribute the exponent into the bracket. And you come up to that result. Okay? So you're expected to know this. This is grade 10. Right? So we are on the 5th law. Now, we also have definitions. Okay? Now, sometimes I think in the lower grades, those definitions, the grade 8 and 9 teachers, they also call them laws of exponents, but they are actually definitions. Right? A to the power of 0 is a 1. You know that. Okay? Any number raised to the power of 0 is a 1. Yes. Yes. Right? A to the power of 0 is a what? It's a 1. Right? So you know this. Your grade 8 to 9 teacher taught you. Alright? So a to the power of 0 is a 1. Then, this one is very important now. Definition number 2. Sometimes it's also called the law x to the power of n. Right? If I give you a base x and I raise it to an exponent which is negative, we can convert the negative exponent to a positive, so that it becomes 1 over x to the power of positive n. 1 over x to the power of positive n. Okay? You did that last day. Right? Then sometimes you can also have a constant multiplying a specific base which is raised to a negative exponent, ax to the power of minus n, like that. Now, with this now, you need to be aware that this definition and this one, they are related. The only difference is that the coefficient of the x there is a 1, here it's no longer a 1. Okay? So where we have got this 1 here, we replace this 1 by the coefficient which is a. So this becomes a over x to the power of positive a. Okay? Then sometimes you can have a base being multiplied by a constant, but the base will be a variable. Okay? So if you are given ax to the power of negative n, okay, because we have got a negative there, be aware that this is also related to that, also related to that. The only difference is that here, the base now is being multiplied by a variable. And both of them become a base. Their product becomes a base, and then they are raised to a negative exponent. So the answer here will be 1 over ax, all raised to the power of n.
So whenever the exponent is negative, we have to make it fraction.
Yes, the negative one. Like example, if I give you a number like say 3 to the power of minus 1. Okay? 3 to the power of minus 1 will be equal to 1 over 3 to the power of 1, which is a third. Okay? Then, now this one is interesting now, whereby you having Okay, in this case, you are going to have 1 over x to the power of minus n. It's now the opposite of definition number 2. Okay, like that. The moment you put 1 over x to the power of a negative exponent, be aware that this is the same as x to the power of positive n. Alright? So you are expected to know these definitions and the laws. Yes?
So by putting the coefficient of your variable, you divide them, you change whether it's positive or negative.
Okay, what is happening here is, it doesn't mean that if the exponent is negative, then the whole number is going to be negative. That's not what it means. It's just that the whole number is going to be, the product here is going to be a very large number. You raise it to the power of negative n, right? If n is negative, the whole answer will still be positive. It's only that we can convert it from exponential form to a fraction by using definitions number 2, number 3, and number 4. Definitions 2, 3, and 4, they just convert an exponential form to a common fraction. Okay? Or you can say they convert an exponential form to a combination of fraction and exponents. Okay? So last year you did that. Okay, so let's talk about some examples. Is there anybody who has got a question? So what you need to do, you need to sit down and memorize that. Okay, so let's do some examples. Can I move on? Can you put your phone on? Why you always want to sleep in class? Lungel, why you always want to sleep in class? Do you go to bed early or what? Yeah, then if you can't go to bed early, then you must wake up in class. No matter what you have to wear, you have to be awake in class. Okay?